Let's take an example in acidic condition now. Acidic condition, that means you have H plus in solution. So an example of dichromate, I took from the web, in aqueous solution, reacting with HNO2, which is an acid, that will give you chromium in solution, plus nitrous oxide. So in this case, sorry, I should write it a bit better. Now this is what I'm giving you to balance. So it's not only the elements but also the charge and everything. It's a redox reaction. How you can actually recognize those redox reactions? Here we have the oxidation state of chromium in dichromate. It's one oxygen, which is in this case -2, plus -2 is going to be 0, so chromate has to be 0. The oxidation state of chromate is 0 here, is +3 here. So this is an oxidation. The oxidation state of N in this reaction here, we have oxygen that is -2 times 2 -4 plus 1H, it's going to be +3. In this case, this is going to be O for NO minus, oxygen is -2, -1 is -1, is going to be +1. So this is a reduction. So you can write the two half reaction. One is the dichromate 2- that will give you the chromium ion, and the second half reaction will be the HNO2 aqueous will give you the nitrous oxide. So that's those two half reactions. Now you're balancing the main elements without oxygen and hydrogen. So for in this case, chromium, dichromium, you have 2 chrome here. Well, 1 chromium, you need 2 of those chromium here. For the nitrogen, both you have 1 nitrogen on each side. I'm not balancing for oxygen or hydrogen yet. Then, step 4, you're balancing oxygen by adding water. Here on the first half reaction, the chromium have 1 oxygen, so we need to add 1 H2O on the opposite side. So now we have 1 oxygen on the right side, 1 oxygen on the left side. Here we have HNO2, you have 2 oxygen in this case. You have 1 oxygen on the other one, you need to add 1 oxygen here too. So you have 2 oxygen on the right, 2 oxygen on the left. Now we're balancing the H, including 0.5, the H2O that you're just adding right now. So we have on the right first half reaction, we have 2H on the right, so you need to add plus 2H plus on the left. Here on the second half reaction, we have 1H on the left, and you have 2H with H2O on the right. You need to add plus 1H plus here. Now the next step is to balance the charge by adding electron. For that you need to calculate the charge on every side of each half reaction. For the first half reaction on the left, we have the dichromium as an aqueous phase has a charge of -2, plus the 2 plus charge, that means the entire left side of the half reaction is 0. This is 0. Here we have H2O is 0, and you have 2 times plus 3. That means this side here of the half reaction is plus 6. So we have a charge of plus 6 in here. So you need to add plus 6 electron on this side, because this has to be neutral. So if this is 0, the right side has to be neutral also. For the second half reaction, we have in this case plus 1 charge here, and here we have -1 on the right side, because H2O is neutral and O- is -1. So you need to add plus 2 electron on this side to have the same charge on the left, to have a minus charge for the left side of the second half reaction. You need to have the same number of electrons on each half reaction. That means you need to multiply this equation by 3. Because you have 6 electrons, 2 electrons on the left, on the second half reaction, the common denominator is 6, so you have to have times 3. That means that the second will be 3HNO2 plus 3H plus 6 electron plus 3NO minus plus 3H2O. I will simplify electron, electron, and I'm going to add those two half fractions now. We have chromium, dichromium, plus 3HNO2 plus 3NO minus plus 4H2O. This is your balanced reaction. And you can see that this is an acidic environment because we are dealing with H plus here. You have H plus in solutions, you can play with H plus. So when you have acidic condition, H plus appear in the equation. In this case, this reaction is consuming acidity, is consuming H plus in your environments. Now let's take another example in a basic environment. Basic condition, you will have OH in solution. So let's take a random equation, something I will not be dealing with in the geochemistry, but doesn't matter, just to illustrate that you can balance any type of reaction. What I'm proposing to do is to take silver as a solid, to put it in water, together with zinc, aqueous solution. That will give you a soluble Hg3 silver oxide, aqueous, and the precipitation of zinc solid. So let's balance this equation. First, recognize the redox equation. Okay. Now we have silver as solid, oxidation state 0, silver in the aqueous solution with oxide, oxidation state +1, right? Because oxygen is -2, so it's a redox part. So we can actually write the first. It's a silver will give you silver oxide, and the second half reaction will be, of course, zinc 2 plus aqueous, giving you zinc solid, oxygen state 0 plus 2. It's a reduction. So this is an oxidation and this is a reduction. So now we recognize those, we wrote those two half reactions, balance the main elements without oxygen and hydrogen. We need 2 silver because you have Hg2 here, and the zinc is perfectly balanced. We are balancing now the oxygen by adding H2O. First equation, we need to add 1 H2O on the left part of the equation because you have 1 O here. You don't have any oxygen on the second equation, you're not balancing anything. Now we are balancing the H, the hydrogen, by adding H plus. We have 2 H plus here, you're adding 2H plus on the right side here. Let's make it more clear here. So 2H plus to balance 1 H2O, you just put on the left side of the first equation. You don't have to balance anything on the second half equation. And then you are balancing the charges. The left part of the first half reaction is neutral, so here to be neutral you need to add 2 electron on the right side. Here you have +2 on the left side. The solid is by definition 0, as oxidation state, so you need to add 2 electrons in here. Then you're adding the 2-half reaction to have the final balance equation. You have 2 silver plus 1 zinc, 2 plus aqueous. The 2 electrons will cancel each other, so you don't have any electron, of course. And then you're adding here plus H2O will give you H2O plus zinc solid plus 2H plus. So here also we are in basic condition, so you cannot write H plus, you need OH minus. So you're multiplying both sides of the equation by 2OH minus here and plus 2OH minus here. That would give you the final results of 2 silver plus zinc 2 plus 2OH minus plus H2O will give you plus zinc solid plus 2H2O. Then you can again get rid of the water here and simplify that to have the final balanced redox equation with 2 silver plus zinc 2 plus your 2OH minus will give you this plus zinc solid plus 1 H2O, and this is your balance equation, redox equation in a basic condition. You see that in this condition you are consuming alkalinity, you are consuming OH minus. So this has a potential without buffering to decrease the pH. And so what I'm going to propose you to do is a couple of example exercise in the assignments to balance a couple of equations, and especially link that to the acid-base chapter by thinking about the one of the question in the assignment.